So now that we know how to classify and look at a three-dimensional shape, let's learn about some of the pieces and the calculations that we can use with them. So we're going to talk about lateral area and surface area. So lateral area is everything except the bases. Okay, so imagine that you're only wrapping the four sides of a box and not the top and the bottom. That would be lateral area. Surface area is the area of all of the surface, including the bases. So lateral area is no base, okay, no bases. Surface area is with the bases. So we're going to have formulas. This is all going to be completely formula based. So that's going to be nice. So your lateral area is the perimeter of the base times the height. Okay, P is the perimeter of the base, so you have to figure out which one the base is, which is what we did the other day. And then surface area is your lateral area, because you already found all of the other sides, and then also your top and your bottom, so plus your two bases. Okay, so P is the perimeter of the base, B is the area of the base, and H is the height. Okay, and so what we need to start learning how to do is we need to learn how to recognize what are all the pieces. Okay, so with a rectangular prism like we have in number 1, it doesn't matter what you use as the base. So most of us prefer to use the bottom as the base, and so there is my B. Okay, so that's what I'm going to use for my base. Now lateral area is PH. Okay, so PH. So I need the perimeter of the base. So I have decided that the base is going to be that blue rectangle. So it'd be 6 plus 2 plus 6 plus 2. So we have 8 plus 8. So my perimeter is 16. Okay. The area of my base, area is length times width for a rectangle. So it'd be 6 times 2. So the base is 12. Now, the height, we want the height of the three-dimensional figure. So you have to get up off of that blue and you have to go up, okay? Or you have to find the distance. So H is the height, but it's also the distance between the bases. So that's another way to think of it, because it's not always going to be vertical height. So you want to think of your height as the distance between your bases. So I have this other base up here on top, right? And so the height between those bases, or the distance between those bases, is 4. So I would use an H of 4. So my lateral area then would be 16 times 4. So my lateral area would be 64 meters squared. My surface area is going to take that lateral area that I just found. I'm going to take that 64. Okay, basically, let me explain. That lateral area gets you all of these, the front, the back, and the right, and the left. So that's your lateral area. Okay, then your surface area is going to be your lateral area plus the two bases. Well, the area of the base was 12, so it's going to be 2 of the 12s. So 64 plus 24 is, it's not right, 64 plus 24, let me double check this. 64 plus 24, I wrote it down wrong, should be 88. And that would be meters squared. Sorry, my key had the wrong answer. Okay, so pH and then pH plus 2b. Now the hardest part is figuring out the base and the height. So that is where it's good, a good idea to highlight the base. So I remember the bases have to be congruent and parallel. Well, I've got rectangles, but none of them are congruent or parallel. So that means the triangles, basically if you have a shape other than a rectangle, that's going to be your base. So there's your base. Okay, now we need the area of the base. So just ignore the rest of the shape. Let's just focus on our triangle for a minute. Okay, focus on our triangle. So we need the area of that base. Well, that means I need the base of the triangle times the height of the triangle. Well, I need the height of the triangle. Remember, we're ignoring the rest of the shape. This is just the height of the triangle. So the area of the base would be half the base times the height. Well, I don't have the height, so let's go find it. Remember, that cuts that in half. If I do h squared plus 8 squared is equal to 10 squared. So we need to use Pythagorean theorem to get that. So h squared plus 64 equals 100. Subtract 64 from both sides, you get that h squared is equal to 36. Square root both sides, and you get that h is 6. So the height is 6. That's also a 3, 4, 5 triangle if you recognize that. So the height of the triangle is 6. So then I can find the area of the triangle is 48. Okay, so the area of the triangle is 48. The perimeter of the triangle is 10 plus 10 plus 16. So the perimeter of the triangle is 36. Okay, then now I need the height of the shape, of the whole three-dimensional shape. Notice everything was based off the triangle, and now the only thing that I need that's going to come from the whole shape is the distance between the bases. This is the height. This is how tall it is. Now, if all else fails and you don't understand how to do this, how to use the formulas, then you've got 3 rectangles and 2 triangles. You can find the area of each of them individually and add them all together. So you do have something to fall back on. So my height is 25. There's my h for the whole shape, the distance between the bases. So my lateral area is my perimeter of the base times the height. So the perimeter of the base was 36, and the height was 25. So 36 times 25 is 900 meters squared. Your surface area, you take your lateral area, the 900, and you add 2 of the bases. Remember, we calculated our bases to be 48. So 2 times 48 is 96. Add that to 900. So the surface area will be 996 meters squared. So that is the area of the 3 rectangles and the 2 triangles. Okay? So number 3. Number 3, we need to find our bases. Remember, our bases are congruent and parallel. So not top and bottom, right? You need to look for congruent and parallel. So what I have is this trapezoid right here. So since the perimeter and the base, the big B, are going to come from that, I'm going to take a break for a second. I'm going to bring all these numbers down here just so I have them, just in case. So I'm going to find the area of the base. The area of a trapezoid. Ignore the rest of the shape, just the area of the trapezoid. Remember, the area of a trapezoid is 1/2 base 1 plus base 2 times the height of the trapezoid, which is 12. So 18 plus 23 times 12, and then divide by 2 is 246. So the area of the trapezoid is 246. The perimeter of the trapezoid is 12 plus 23 plus 20 plus 18. So the perimeter of the trapezoid is 73. Then I need the height. Remember, it's the distance between the bases. So the distance between the bases is 15. You have to leave that two-dimensional figure. If all you use is the bases and the heights and everything of the trapezoid, then I never went back. Imagine that you're pushing this trapezoid into like Jell-O and you're leaving a hole, right? You're pushing it into a form and you're leaving a trapezoidal hole is what you're doing. And so I'm going to push that trapezoid back 15 feet. That's going to be the height. That's how deep my trapezoid is. Okay, so the height that I'm going to use for my formula is the 15. So your lateral area is your perimeter of your base times your height. The perimeter of my base is 73. My height is 15. So 73 times 15 is 1,095 feet squared. Take that lateral area, right? That's all of your rectangles. That's your top, your bottom, your right, and your left rectangle. That's just your rectangles. Now let's add in our 2 trapezoids. So we're going to add back in our 2 trapezoids, which our trapezoids were 246 feet squared a piece. So if I add those back in, then I get 1,587 feet squared for my total surface area. That's all 4 rectangles and both trapezoids together. Okay, so the perimeter and the base, the P and the B, come from just the base. The height comes from the 3-dimensional figure, the distance between the 2 bases. Now, a cylinder works the same way. But a cylinder, instead of having all the different shapes, see P, H, and B, we can use because it doesn't matter, we can use different shapes, right? We can use different shape bases. Now, for a cylinder, our base is always a circle, and so we need to use the area of a circle. So recall that our area of a circle is pi r squared. So our lateral area, that's going to be your green bean wrapper. Okay, so that's your basically, let's put this down, that's your green bean can wrapper, right? Your total surface area that's your top and your bottom and everything, okay? That's all total surface area. That's all of your bases and everything, okay? So our lateral area is 2 pi RH. 2 times pi times r. Now notice, 2 pi r, that is the circumference. Well, if you remember back to our prisms, it was pH. Well, this one is CH because circumference is the perimeter for your cylinder. So we use the equation 2 pi RH. Then our total surface area, that's our wrapper, right? Then we're going to add our two circles. So we're going to take our lateral area, 2 pi RH, and we're going to add the top and the bottom circles. So 2 pi r squared. So we're going to use everything that we can get from our shape. Now we like cylinders because there's, all you've got is a radius and a height. So my lateral area, that's 2 pi RH. I always recommend that you write your formulas because it just helps it to know what you need to plug in. Okay, so we have 2 and then pi, and then my radius was 3 and my height is 6. Now, one of the things we like to do is we like to leave our answers exact. What that means is multiply everything except the pi. 2 times 3 is 36, and we didn't multiply the pi, so we're going to leave it 36 pi. That just means 36 times pi. I just didn't multiply it out. So that would be in terms of pi, which is approximately, if you do 36 pi on your calculator, you get 113.1 meters squared. Now, if I want my total area, remember, is to take your lateral area, your 36 pi, and add two circles, your top and your bottom. So I'm going to add 2 pi r, which was 3, squared. Now again, we keep our 36 pi, let's just keep it. We like to deal with exacts for at least a little bit. So 2 times 3 squared, 2 times 3 squared, that's 2 times 9, it's 18. So it's 18 pi. Well, 36 pi plus 18 pi is 54 pi. Now I just want you to be aware that this exists. You don't usually have to do your answers. We're usually going to say round to the nearest. So you can type in everything exactly. You could do this. You could do 2 times pi times r times h plus 2 times pi times r squared. You can type that in on your calculator and you will get 169.6 meters squared rounded to the nearest tenth. Now, if you were to type in 54 pi on your calculator, you know what you get? 169.6. Same thing. Okay, so it can all be typed in on your calculator just by using your formulas. So just pay attention to which one, because it's the radius that gets squared, not the height, right? That's your radius, that's your height. So the surface area of the soup can below is 51.84, surface area, okay? So that's how much metal it took to make the can. If the diameter of the can is 3 inches, so the diameter of the can all the way across is 3 inches. Find the height of the can. So as soon as you see surface area, let's write our surface area equation. So our surface area is equal to 2 pi RH plus 2 pi r squared, straight from the formula chart, okay? So then let's plug in everything we know. Let's substitute everything in we know. So my surface area right here is 51.84. So I'm going to replace that with 51.84 equals 2 pi is a number times pi times r. Okay, well we don't have r, but we have diameter. Well, if our diameter is 3, then our radius is half of that, so it's 1.5. 1.5. We don't know our height. That's what we're trying to find. Plus 2 times pi times the radius, again, squared. Now, here's probably the easiest thing that you can do. Go ahead and do any math that you can do. Okay, I can do this math right here, and I can do all of this math right here. I can multiply all that out. That's all stuff I can type in on my calculator. So 51.84 is equal to, if you do 2 times pi times 1.5, you're going to get 9.425. It's a good idea to keep several decimal places and then not round until the very end. Plus, type in this 2 times pi times 1.5 squared, and you get 14.137. Again, I just kept 3 decimal places so that when I round at the very end, it will be more accurate. So now, you want to go in and you want to solve this problem. Don't let the decimals scare you, right? This looks just like, say for instance, this is what it looked like. You wouldn't even hesitate. You would know how to work that problem. I just made this up so you can see. Don't let the decimals scare you, okay? So come over here, subtract 14.137. So if I take 51.84 and subtract 14.137, I get 37.703, that cancels out, equals 9.425H. And if I divide by 9.425, because that's how I separate it from that, times H, I get 4. So see, it looks like this. So you would get H is equal to, and it's a whole lot of decimals, and we wanted to round it. The height of the can is 4 inches. Okay, so you want to, this is just a practice in how to use the equation. So as soon as you decide that it's surface area, because it said the whole surfaces, all the surfaces, if it just said the area of the wrapper, that would be lateral. Okay, use the formula, plug it in, do all the math that you can do, which we did right here, and then just start working through the algebra to make it work. So we have formulas for the area of our cylinders, and we have formulas for the area, lateral area and surface area of our prisms. For your prism, the base is what's going to decide whether it's a triangle or a rectangle or a hexagon or pentagon or whatever it is. That's your P and your B. And then your height is always going to be the distance between the two bases, and it's the same thing here. The height is the distance between the two circles. Okay, so use your formulas, know how to use those.